Yes, so hello everyone. This is lecture 10 on your computer networks. And in this lecture, we are going to start our. Okay, only two topics were left out. Now, I have told you efficiency of CSMA. Okay, more precisely CSMA CD. Efficiency, I'm just giving you the formula. I'm not going into derivation because it will waste our time. 1 upon 6.44a. So now a is the same, TP upon TT. Okay, so you can answer any type of question if gate asks regarding this topic. Okay, so they will simply give you TP, they will simply give you TT, and they will expect you to find the efficiency of CSMSED. You can easily find it out. I think there is no doubt. We have done many efficiency questions in your SR, go back, and everywhere we have done these kind of things. Okay, so I think you already know, no? 1 upon 1 plus 2a for stop and wait. Okay, for GBN it was n upon 1 plus 2a. Okay, and for SR also n upon 1 plus 2a. Okay, and for this CSMA efficiency is 1 upon 1 plus 6.44a. Okay, so you should remember this thing, so you can answer many questions. If you want, then I can give you a small numerical, otherwise you can do it yourself. It's really very simple kind of thing. So you just have to put the formula and get the answer, that's it. So this type of question, if they are asking such question, you are very lucky. You can answer them very easily. Just apply the formula and get the answer. Okay, that's it. So this is all about efficiency of CSMACD. You can take the snapshot. I will jump to the next slide, and then I will tell you about flow chart or flow diagram of CSMA-CA, which was left out in the previous lecture. Take snapshot. Done.
Done, sir.
Okay. So next is CSMA-CA flow chart. So this flow chart will give you basic working of CSMA-CA. So we will start with okay. So here I'm starting. So start. Okay, let me take another color and start. So we have just started, and then your attempt will be zeroth. That means your first attempt, or zeroth attempt. It is k is equal to 0, and it will sense the channel. Is it idle or not? Idle channel. Okay. If it is answer is no, then it will keep on sensing the channel till it finds idle. If it finds the channel idle, I have told you it will not send the frame immediately, rather it will wait for IFS time. Try to remember, in the previous lecture itself we have discussed wait for IFS time, interframe space time. Okay, so now even after IFS, is it still idle? Still idle. Okay, so if answer is no, then we will come back here itself. If answer is no, that means again you will wait for IFS time and so on. You keep on checking. So I think you have got it. If channel is if channel is not idle, then you will keep on checking till channel is idle. Once you got the channel idle, you will again wait for IFS time. Okay, now if by chance channel is still idle, then what you will say? You will not immediately send the frame. I think you already remember, we have told you that we will wait for contention window time. Okay, so what was contention window? Choose a random number R, choose random number R between 0 and 2 power k minus 1. Okay, we will choose a random number R between 0 and 2 power k minus 1. Wait are empty slots. Wait are slots, and in bracket I have written empty because we want to wait for empty slots. Okay, and then send the frame. Okay, after that we will send the frame. Okay, after sending we will wait for timeout. Wait for timeout. Okay, and then we will say, I have told you na, even after these many precautions, even then collision may occur. So we will wait for acknowledgements. That's why we have said here, after sending frame, we will wait for timeout. Okay, if ACK is received, then it is success. Otherwise, you will increase the attempt and so on. So ACK, yes, yes, then we will say we have got the success. Okay, and if answer is no, you have not received the ACK, then attempt will increase. K is equal to K plus 1. Same scenario, K greater than K max, K greater than K max. Yes, then we will abort the session. No, then we will go ahead. Okay, rather we will go way back to the previous thing from starting itself. The answer is no, then we will again do this thing, idle channel and so on. We will keep on waiting. So let me put everything on one slide. Yes, now you can take the snapshot. Okay, this is the flow chart. I think it's self-explanatory. There is nothing to explain. If anybody is facing any difficulty, please let me know. I will try to explain it. Otherwise, we will start our next topic. Yes, any doubt here?
No, sir. Clear, sir.
Okay, so take the snapshot. I will jump to the next slide, and we will start our next topic that is very, very important. That is Ethernet. Okay. Yes. So the next is we are going to start Ethernet protocol. Ethernet protocol. Okay. So what is Ethernet and why we are using it? Let me first tell you that thing. See, actually, IEEE, Institute of Electrical and Electronic Engineering, IEEE started a project called 802. Okay, IEEE started project 802 so that different LANs can be interconnected. Okay, so when internet was developed, see what is internet? Internet is network of network now. So these are different LANs. Now they might be using different protocols. So how you will connect them? Okay, or how data transfer will done between them? Okay, so for that IEEE started project 802. It was long back in 1970s around. Okay, it was very old scenario. So IEEE started this project 802 so that different LANs can be interconnected. Okay, so for that it has given certain numbers. Okay, so first was a IEEE 802.1. It was for bridged LANs. Okay, bridge is not in your gate syllabus, so we will not cover that, but I am just giving you information. Okay, IEEE 802.1 for bridge LAN, 802.2 for LLC, that is logical link control. These are not in your syllabus. I'm just giving you the idea. Okay, and IEEE 802.3 was your Ethernet, which is in your gate syllabus. Okay, and then we have IEEE 802.4. Okay, so IEEE 802.4, that was token bus, then token ring, and so on. There were many you can say standardizations which IEEE has given. Okay, so from that I'm not going into details because it is not in your GET syllabus. So our main focus will be on IEEE 802.3, that is Ethernet. Okay, so let me start it. So take the snapshot. I will jump to the next slide. So I have just built the background that why Ethernet was developed and so on. So it was developed so that different LANs can be interconnected. Okay, to connect different LANs, this protocol was developed. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So why we are calling it as Ethernet? First of all, let me tell you that thing. Ethernet. Okay, why we are calling it as Ethernet? Ethernet is word comes from the word ether. Okay, ether. I think you know when physics was developed, when a lot of research was done on space, then everybody think that space is not empty. There is some material called ether. It is just like a liquid. It is floating everywhere, and all the planets like Earth, Mars, Jupiter, and so on, all these planets are floating in this ether kind of material. So there is a material called ether which is present everywhere in the space, and all these planets are floating in this ether material. So from that, Ethernet has come into the picture. So why we are calling it as Ethernet? Because here signal will be transferred to everywhere. Okay, everywhere signal will be transferred. That means it is not like that. If A and B are communicating, like I have told you many times, A, B, C, and D. So if this is Ethernet LAN, so what will be done? When A and B are communicating, even then this signal will go everywhere. Okay, you cannot control it. Signal is current. Current will flow on wire. We cannot control it. So that's why this term Ethernet come into the picture. So ether means everywhere, material which is floating everywhere. So same is the scenario here. Signal will go everywhere. We cannot control the signal. Okay, that's why this term Ethernet come into the picture. Okay, yes. So now actually Ethernet has many, you can say many versions, or you can say if we talk about Ethernet evolution, then the very first which was developed was standard Ethernet. Standard Ethernet. Okay, just a second. Standard Ethernet, and then we have fast Ethernet, and then 1 gigabit Ethernet, and then 10 gigabit Ethernet. Okay, so there are 4 versions of Ethernet. We will study this standard Ethernet only because this is in your GATE syllabus. Rest other we are not going to study. It is simply wastage of time. And let me tell you the bandwidth. That is important. For standard Ethernet, bandwidth is 10 Mbps. For fast Ethernet, it is 100 Mbps. For this will be 1 Gbps. I think you have got it from the name itself. And here 10 Gbps. 1 gigabit per second, 10 gigabit per second, 100 megabit per second, and 10 megabit per second. This is bit. Okay, don't consider it as byte. So let me write it if you are getting confused. 1 Gbps and 10 Gbps. Small b. Okay. So it's small b. So this is all about Ethernet evolution, that how it was evolved and so on. We are going to study only this standard Ethernet. Okay, that means 10 Mbps. And anyway, actually technologically they are almost similar. Okay, but there are few differences, but we are not going into that thing. If they say bandwidth is 100 Mbps and question is about Ethernet, so you might think that it is fast Ethernet question, but don't worry. Whatever I am going to tell you, you have to follow that procedure only to answer numericals and so on. Okay, so we will follow standard Ethernet procedure only. Yeah, take the snapshot. I will jump to the next slide, and now we are going to start this detailed version of standard Ethernet. Okay, detail of standard Ethernet we are going to start. Take snapshot. Done.
Done, sir.
Okay, so this first of all we will study IEEE 802.3 MAC frame. So at MAC level, how this Ethernet frame look like, I have to tell you that thing. So basically we are going to study header. Okay, so since Ethernet is working at data link layer, so it will add header as well as trailer to the data. Okay, whatever datagram which you have received from network layer, to this datagram we will attach header as well as trailer, and this entire thing is known as frame. So now, what are the things in header? What are the things in trailer? We have to study these things now. That's why we have written the topic IEEE 802.3 Mac frame. So how this frame look like? What are the contents of header? What is the content of trailer, and so on? We are going to study that thing. And let me tell you one thing. We will study 3 headers in your rather 4 headers. Okay, we will study 4 headers in networking, and these are very important. Many questions have been asked. First is the this Ethernet. We are going to study today itself. Ethernet header we have to study. Okay, rather how this frame look like, header as well as trailer, we will study. Next is your IP header. Question have been asked in gate. So many questions like this field is of how many bits, this field is of how many byte, what is the use of this field, and so on. So header, content of the header. IP header means IP protocol is at network layer, no? So network layer will add header. Okay, so how this header look like, what is the size of the header. Okay, there are many fields in that, so what is the size of which field. Okay, and what is the use of this field, and so on. This type of question have been asked in it many times, so you have to remember it properly. I will tell you this thing, IP header. Next, we are going to study TCP header. Many questions have been asked from this also, and we will study UDP header also. So UDP header is very easy, no need to worry. So these two we will study at transport layer, this we will study at the network layer, and this we are studying at data link layer. So total 4 headers are there in your gate syllabus, and all of them are very important. Almost every time you might face one of the question from these 4 headers. Okay, almost every time one question will be asked from these 4 headers, and it's your luck on which header question will be asked. Okay, but these are very important, so please try to listen these things very carefully. Okay, so now we are going to start IEEE 802.3 Mac frame. So let me start it. So the very first field is preamble. Okay, so let me write it here. Preamble. Next is SFD. Start frame delimiter. Destination address. Source address. Length or type field. Data plus padding. And then CRC. CRC, that is cyclic redundancy check. So they might ask you Ethernet is using which error detection technique it is using. CRC. Okay. Yes. So preamble is 7 byte. SFD means start frame delimiter. Start frame delimiter. Okay, it is 1 byte. Next, destination address 6 byte. Source address 6 byte. Length or type 2 bytes. Data padding 46 to 1500 bytes. Variable length frame. Okay, 1500 bytes. CRC 4 byte. I think if you try to remember, I have told you na, CRC 32 it is used in Ethernet. Try to remember when I was teaching CRC error detection technique, I have told you CRC 32 is used in Ethernet. So here we are using it. 32 means 4 bytes. So this 4 byte CRC. Okay. Yes. So preamble, SFD, destination address, source address, length of type, data plus padding, and CRC. These are the fields. Okay. And one more thing, this preamble and SFD, these two are added by your physical layer. These two are added by physical layer, and these are not part of Mac frame. So I have written the heading IEEE 802.3 Mac frame. So Mac frame is starting from here. Okay. So it is starting from here and it is going till here. Okay. So this is your IEEE, this is your Mac frame. Okay. Mac frame. So try to answer basic question. So very first basic question will be minimum frame size. Minimum frame size. You can answer from here. It will be destination address 6 plus 6 plus 2 plus minimum data is 46 plus 4. If you calculate it, it comes out to be 64 bytes. Okay, and 512 bits, one and the same thing. So they can ask to twist the question, they can ask in bits also, they can ask in bytes also. 64 bytes, 512 bits. Very very important question. Many times this has been asked. In sometimes in match the following, sometimes indirectly they will ask. Okay, and next is maximum frame size. Maximum frame size. 6 plus 6 plus 2 plus 1500 plus 4. It comes out to be 1518 bytes. Okay, so minimum frame size is 64, maximum is 1518. Very very important point. Okay, so Ethernet frame. So clearly you have got it. Ethernet frame is, it is not fixed size frame, it is variable size frame. Ethernet frame, first point, it is of variable size. Variable size. Okay, minimum is so 64 to 1518 bytes. So what are the overhead? 46 byte data, then overhead is 6 plus 6 plus 2 plus 4, 18. So 18 byte overhead. 18 byte overhead. So this is including header and trailer. Including header and trailer. So because of header, overheads is 14 byte. Okay, 14 byte header. 14 byte header and 4 byte trailer. You should have to remember these points. Very very important. Many times question have been asked. So Ethernet frame, header overhead 14 byte, or header size 14 byte, trailer size 4 byte, 18 byte overhead total. 14 plus 4, 18 byte overhead including header and trailer. Minimum frame size 64, maximum 1518 bytes, and Ethernet frame is of variable size. You should remember these points. These are very very important. Okay, and why we are taking minimum data, and what is padding, what is length or type, don't worry, I will tell you each and everything, don't worry. Okay, I have just started this topic, so these are very important points which was coming into in my mind, that's why I have given you. So take the snapshot, take the snapshot. I will jump to the next slide. Okay, and then we will start one by one introduction to these fields.
Done, sir.
Okay, so the very first field is preamble. Preamble, and this is added by physical layer. It is not part of Mac frame, but still we have to study these points. They can ask. So preamble is alternate sequence of 1 zeros, like 1 0 1 0 1 0 1 0 and so on. How many? 7 byte na, 7 byte. So 7 into the 56. So 56 bits are these 1 0 1 0 like this. So what do you think? Why we are adding it? Because this is of variable length. Frame is of variable length. So we will send first preamble so that receiver get to know that something is going to come, like this on off, on off, on off. Light is coming, going, coming, going, coming, going. So receiver will come to know, okay, something is going to come now, I should be get ready. So this is just for synchronization purpose. Okay, so alternative sequence of ones and zeros. So it is just giving warning to the receiver that frame is going to come. Okay, so it is used for synchronization purpose. So warning to receiver, because variable length frame hai na, that's why. Okay, if it is a fixed length frame, no need to do any kind of these things. Okay, so okay, so warning to receiver that frame is going to come. Frame is going to come. Okay, and what is the basic use? Warning. Why we are warning? So that it gets synchronized. Okay, it get ready. Okay, so it is used for synchronization purposes. Synchronization purposes. Okay, preamble. Next field is SFD. SFD or start frame delimiter. So next is SFD or start frame delimiter. This is 1 0 1 1 byte. Na, see this 1 byte, 1 byte. So 1 byte is 1 0 1 0 1 0 1 1 like this. So SFD is the, you can say, start frame delimiter. It is the second chance to the receiver. Okay, if by chance receiver is, let's suppose it is sleeping, so we have sent preamble so that it get wake up. But if still it does not get wake up, so this is the second chance to receiver for synchronization. Okay, and this double one, in last double one means now the next field which is going to come is your destination address. That means your MAC frame is going to come. Double one means MAC frame is coming now. MAC frame is coming. Okay, or you can say the next field is destination address which is going to come. So SFD is, you can write this one line, last warning to receiver that frame is going to arrive. Last warning to receiver that frame is going to arrive. SFD is last warning to receiver that frame is going to arrive. And last two ones, these two ones, last two ones tell the receiver that next frame and next field will be destination address. Okay, so last two one tell the receiver that next field is going to be destination address. Next field is destination address. Okay, so let us check the next field. Destination address, source address. So don't worry, we will start it, but I just want to complete these basic things first. So let us study this length or type field. Okay, so next we are going to study is length or type field. See, in original Ethernet, when this Ethernet protocol was developed, this was the type field. Okay, this was the type field in original Ethernet. Original Ethernet. Okay, and this means type field means which upper layer protocol is using this MAC frame or Ethernet frame. Original Ethernet, it was type field, and this means which upper layer protocol, which upper layer protocol is using this Ethernet frame. So what do you mean by upper layer? We are talking about MAC, na? So upper layer is LLC, logical link control. I think you already know. I have told you IEEE divided your data link layer into two parts, LLC and MAC. Okay, we have already studied this LLC. Now we are at MAC. So this type field was indicating which upper layer protocol. That means which LLC protocol is using this MAC frame. In original Ethernet, this was the case. Okay, but when IEEE standardized this Ethernet, see, Ethernet protocol was developed in computer networks. General scenario is that somebody developed this protocol. Okay, generally any protocol, someone will develop it. Some scientist or somebody will develop it. Then this standardizations authority will come into the picture, like IEEE, ISO, and so on. There are many standardizing authorities like IEEE, ISO. ISO is International Organization for Standards. Okay, and so there are many organizations. So when they certify this, so like this, you have developed something, you want certification. So you will go to some agency that please certify my product and so on. So when IEEE certified this Ethernet, so they make some changes. And that is just human nature also, some ego problem, you can think like that. So whenever any authority standardize some protocol, they will not keep the thing as it is. They will change few basic things. So like this, IEEE changes this type field to length field. And what was the claim? They said that whenever we will use, whenever any company will use IEEE standardized LANs, in that case LLC will use only one protocol called PDU or Protocol Data Unit. There are no different protocols. I have told you na why IEEE started this project, so that different LANs can be interconnected. So if you want to connect different LANs, then their protocol must be same. So at LLC, every LAN should use one protocol, that is PDU or Protocol Data Unit. Okay, so then what is the use of this type field? Because every LAN will be used PDU only. So they change this type field to length field. Okay, that's why IEEE, when IEEE standardized this Ethernet, then they change this type field to length field. Okay, you can write it. You can write it. But in IEEE standardized LANs, Okay, write it like that. Okay, you have written this thing now. Original Ethernet, which upper layer protocol is using this Ethernet frame. Okay, upper layer
Yes,
means
sir.
LLC. Type is over. Now I am telling you about the length field. So when IEEE standardize Ethernet protocol, when IEEE standardize this Ethernet protocol, okay, then it change this field to length field. It change this field to length field because in IEEE standardized LANs, because in IEEE standardized LAN we have only one protocol, we have only one protocol, that is PDU. We have only one protocol, that is PDU. In bracket you can write protocol data unit. We have only one protocol, PDU, that is protocol data unit, which works at LLC, which works at LLC. Okay. So that's why we have this length field. So IEEE changed this type field to length field. Okay. And what does this length field denote? It denotes amount of data carried in MAC frame. You have to remember this thing. Amount of data carried in MAC frame. Okay. It is not header plus data. It is not total length. You will get confused when we will study this. See this. I have told you na many header we have to study. So when we will study IP header, TCP header, you might get confused because there we will have total length field. Here it is not total length. It is just length field. Length means amount of data carried in MAC frame. So let me write it properly. Excluding header. Excluding header. Do not consider header in it. Header or trailer. Excluding HT, I should write like this, header or trailer, excluding these things. So amount of data carried in MAC frame, excluding header or trailer. Okay, that is about the length field. So I hope you have got the point. Okay, next is data plus padding. Let me tell you that thing also. Take snapshot.
Done, sir.
Okay, so data plus padding. Data is okay. Data is your datagram, whatever network layer is providing you. What about this padding? Okay, I have told you now minimum data is 46 bytes and maximum data is, okay, let me write it here. Data plus padding, minimum is 46 bytes and maximum is 1500 bytes. I have told you. So now why we need this minimum 46 bytes? Okay, now what if you have only 20 byte of data? Then what you will add? You will add 26 byte padding. Padding means garbage data you will add. Okay, if we have 20 byte data, but minimum is 46 bytes, so we will add 26 byte padding. Now question arises, why this minimum frame size? Why minimum 46? Okay, why minimum 46? Why minimum? Because here we are using CSMA-CD, and in the previous lecture only I have told you CSMA-CD. I think if you try to remember, I have told you CSMA-CD with one persistence method is used in Ethernet. So CSMA-CD with one persistence is used. With one persistence is used. Now since CSMA-CD is used, so obviously we need minimum frame size. Because if we do not need, if we do not have minimum frame size, then obviously frame will get out of the receiver. Oh, sorry, entire frame will be sent by sender, and then it will detect the collision. Then what is the use of detecting collision? Because entire frame has been sent by sender. Okay, so minimum frame duration must be 2 TP time. I think you try to remember. I have told you in the previous lecture only. Minimum frame duration must be 2 TP time. Okay, so for 2 TP time, frame must be sent. So 2 TP multiplied by bandwidth, 2 into TP into bandwidth. Okay, and that was the minimum frame size for CSMA-CD. So from that calculations we have done this, that 46 byte is minimum. Okay, and 46 byte frame data is there now, so header is also there. So minimum MAC frame was 64. I think you already remember. 18 byte overhead, na? So frame will become 46 plus 18, that is 64. And it will become 1500 plus 18, that is 1518. So if they say Ethernet frame, minimum size of frame for Ethernet, it will be 64. Maximum frame size 1518. Both question have been asked. Minimum data in the frame 46 byte. Maximum data inside frame 1500 byte. Okay, you should remember these things properly. Okay, so I think you have got the point. If you have only 20 byte data, then 26 byte padding will be there. So I hope you have got the point. Yes, so you can take the snapshot of this, and then I will tell you about this why this maximum 1500 bytes was there.
Done, sir.
Okay. Yeah, and one more thing I want to tell you, that this 46 byte 26 if 20 byte data, then 26 byte padding is there. So what will be the length field? Length field will indicate only 20 bytes. Okay, padding is not included in it. So that is the basic use of length field. Length field will give you information about what is the size of, or what is the length of data inside your datagram. Sorry, data inside your Ethernet frame. Okay, so I have told you, see this, I have written here, amount of data carried in MAC frame. I have not said about padding. I am not saying that thing. I am just saying amount of data carried in MAC frame. I have not said about anything about padding. So this is data only. So 20 by data, then length field will contain 20 only. Okay, it will not contain 46. Okay, it will not contain 46 because padding is not included here. Okay, because if padding is there, then you might argue with me, sir, how receiver will come to know about whether there is padding or not? So it will come to know from this length field. Okay, so I hope you have got the point. So data and padding, these are differentiated at receiver side with the help of this length field only. That's why length field is very important. Okay, take the snapshot. I will jump to the next slide. Done. Okay. Yeah, so next is this why maximum 1500 bytes. Okay, why 1500 byte data? Because it has historical reasons. When Ethernet was developed, then bandwidth available was very less. Bandwidth was less. Okay, now in today's world we have 10 Mbps, 100 Mbps, 200 Mbps, but at that time it was in just kbps, 1 kbps, 2 kbps, like that. So bandwidth was less at that time when it was developed. So if 1500 byte was more than sufficient, okay, it need very lot of time to transfer 1500 bytes. So bandwidth was less at that time. Okay, and the second was cost of the buffer was also high. Cost of buffer, that means memory. If see, if sender send the frame, receiver will receive it. So receiver has to store it in temporary memory, that is RAM, and then it will process it. So memory was very costly at that time. So that's why cost of buffer was very high. Okay, so they have kept this number. Okay, bandwidth was less at that time and cost of buffer was high. That's why this maximum is 1500 byte. Okay, yes, that's it. So now see this. We have covered this data plus padding. Last is CRC. CRC, I think I have told you. We have already completed CRC. CRC 32 is used here. CRC 32 in Ethernet. I have told you. Okay, yes. So that's it. So now we are going to start addressing. Okay, how addressing is done. I have left out only two fields now. This destination address and source address. So let me tell you that thing also. Addressing in the Ethernet. Yes. So next topic is addressing in Ethernet. Okay. Yes. So addressing here is, I think you have got it. We have 6 byte addresses. Okay, 6 byte physical address, because data link layer is adding physical address, na? Network layer is adding logical address. So 6 byte physical address. Okay, and 6 byte means 48 bits. So both have been Ethernet uses how many bits address? 48 bit address or 6 byte addresses. Okay. Yes, and how this 6 byte address is represented? It is represented in hexadecimal notation. Representation, I'm telling you. Representation. How this is represented? Hexadecimal notation, separated by colon. Separated by this colon. Because 48 bits, if you write it like this, it is very difficult to read and write. That is very difficult. So that's why we are not using binary. We are using hexadecimal notation. For example, I can give you A, B, C, D, E, F, 1, 2, 3, 6. Just as an example. This is an example of MAC address. So they can ask like this also. MAC address is of how many bits? 48 bits or 6 bytes. Because by default only we have one protocol in your gate syllabus, that is Ethernet. There are many other protocols, but we are not going into that because it is not in your gate syllabus. So by default, if they say MAC address size, you will say 48 bits or 66 bytes, one and the same thing. So as an example, I have given you this thing. Okay, so hexadecimal notation separated by column. Okay, one byte, we will write one byte and then separate by column. So 4 bit plus 4 bit, I think you know na how hexadecimal. A is 1011, so 1010. B is 1011. Okay, this 8 bit is over. Now CD, so C is 1100. Okay, and then D is 1101, and so on. I think you know these things or not?
Yes, sir. We know it, sir.
Okay, yes, then good. So this is the way to represent the MAC address. Okay, yes, and there are 3 types of MAC addresses. Let me tell you that thing. Take snapshot. I will jump to the next slide.
Okay, sir.
Okay, so these are of 3 types. MAC addresses are of 3 types: unicast, multicast, and broadcast. Okay, so how you will come to know that this address is unicast or multicast or broadcast? So for that you have to check the first byte last bit. First byte last bit. If it is 0, then it is unicast. If it is 1, then it is multicast. I think you already know unicast, multicast. I have told you unicast means 1 to 1. Multicast means 1 to many. Broadcast means 1 to all. And do I need to write these things or you already know? I have told you, na?
We know it, sir.
Okay, so 0 means unicast, 1 means multicast. Okay, so for example, I can just give you idea. So first byte, last bit you have to check. Okay, so if we say A, B, 1, 2, 3, 6, randomly I'm writing 4, 5, 7, 8. Next is F, A, 1, 2, 4, 5, 3, 6, 2, 3. Okay, so how you will check? Is this address unicast or multicast? So this is first byte, last bit you have to check. For B, what you will write? B is this. So last bit is 1. 1 means multicast, so you will say this is multicast address. Here you have A. A means 1010. So last bit is 0. So you will say it is unicast. Please let me know if anybody is facing any difficulty.
No, sir. Understanding it, sir.
Okay, and the last is broadcast. Broadcast is only one address, that is all ones. Broadcast means all ones, that is FF, 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 FF. So you can check that out whether it is legal or illegal. Say 8 bits, na? 1, 2, 3, 4, 5. 8, 5 the 40. So no, it is illegal. You have to write one more thing. Okay, so 6 you have to write. I think here also I have done mistake. 36, 20. Roughly you should write. Okay, so see this 1, 2, 3, 4, 5, and 6. So 7 at the 56. Oops, 8, 6 the okay, 1, 2, 3, 4, 5, and 6. 8, 6 the 48. 48 bit na, that's why. 1, 2, 3, 4, 5, 6. 8, 6 the 48. Okay, 1, 2, 3, 4, 5, 6. Yes, 8, 6 the 48. Yes, it's okay. Okay, so this is the way to check addresses. Yes, any doubt here?
No, sir.
So if you can say if packet is having this address all ones, then every station in LAN will receive this packet. That is the basic meaning of broadcast. Okay, so they can ask this type of hypothetical question. Okay, so we have a LAN, we have a computer A. Computer A want to send packet to or want to send frame to every other computer in the network. So what address it should use? It should use all ones. Okay, if it use all ones, then every station in the network will receive the frame. Okay, yes. Now they can ask very simple question like how many unicast addresses are possible, how many multicast addresses are possible. They can ask this also. Okay, so how many unicast and how many multicast unicast addresses, how many unicast are possible? See, it is of 48 bit na, so 48 bits means 2 power 48. Total address is possible at okay, let me write it like this. So first of all, total physical address is possible. Total number of physical addresses, that is 2 power 48. Why? Because 48 bits. 48 bits means 2 power 48, like 2 bits are there. Simple, if you say 2 bits are there, so how many addresses are possible? 0001 1011. So how you have got it? 2 power 2. Okay, similarly if we have 48, so see this, here 2 possibility, here 2 possibility, 2 into 2, that's why 4. If we have 2 bits, we will say like this. If we have 48 bits, so 2 into 2, 48 times, so that is 2 power 48. Total number of physical addresses are 48. 2 power 48. Okay, so how many of them are unicast? So you have just reserved one bit na. For first byte, last bit, if it is 0, then it is unicast, otherwise it is multicast. So 0 means what? So first byte, last bit. So directly indirectly I want to say 48. They are total as 48. So everywhere 2 possibility is there, but at the eighth place only one possibility, that is, and rest everywhere 2 possibility. So it is nothing but 2 into 2, 47 times. So unicast is 2 power 47. Any doubt?
No, sir.
Okay, what about my multicast? Multicast, again same scenario, 2 power 47. So you have divided total 2 power 48 into 2 parts, 2 power 47, 2 power 47 each. Now you might argue, sir, where is this one? Broadcast. So broadcast is a special case of multicast only. Okay, so no need to worry about it. You just remember this thing. 0 means unicast, 1 means multicast. So obviously all ones are there. So this first byte, last bit is 1 only. No problem. So broadcast is a special type of multicast only. No need to worry. Okay then. So I can simply say that total there are 2 power 48 IP addresses. You have divided 2 power 48 physical addresses, and you have divided it into 2 parts, 2 power 47, 2 power 47 each. So 2 power 47, and that is your unicast, and this is your multicast. That's it. Okay. Yeah, this is the summary. So this is more than sufficient. Gate will not ask beyond this. Okay, so no need to worry. Okay. Yes. So you can take the snapshot. I will jump to the next slide.
Perfect, sir.
Okay, and if I want to say, they can ask like this also. Minimum transmission time. Minimum transmission time for standard Ethernet. It will be what? Transmission time is what? Message size upon bandwidth. Okay, minimum transmission time for Mac frame. For Mac frame for standard Ethernet. Now they can ask this type of question just to check whether you have an analytical skills or not. So message size is 64 byte minimum, na 64 byte. Bandwidth is standard Ethernet is 10 Mbps. So 10 into 10 to the power 6 bits per second, and here we have 64 bytes. So you have to convert it into bits. That means 512. Let me write it below. So 512 divided by 10 into 10 to the power 6, that is 51.2 microsecond. Like this they can ask. Okay. So minimum transmission time for Mac frame for standard Ethernet, it will be 51.2 microseconds. Okay.
How did we change this 64 to 55 also?
64 bytes, 64 byte to bits you have to convert into 8.
Right, sir. Right, sir.
So 512 is our answer. Okay. Now now they can see there are many types of numericals. If they want to ask, they can ask any type of things. Okay, so the basic thing is transmission time they can ask, that is 51.2 microsecond. Okay, yeah, and if they say yeah, that is okay, so if they say propagation time or TP is given to us as, or RTT. Okay, let me write it. RTT is 51.2 microsecond. Okay, and they are saying speed of signal is say 2 into 10 to the power 8 meter per second, and they are saying maximum distance of, or you can say maximum length of Ethernet LAN. So they are just trying to confuse you. Maximum length of Ethernet LAN. So I think you already know RTT round trip time is 51.2 microseconds. So what will be TP? Propagation time will be 25.6 microseconds. Okay, and speed is given, time is given, to anybody can calculate distance. Distance is equal to speed into time. Speed is 2 into 10 to the power 8 multiplied by 25.6 into 10 to the power minus 6. So it comes out to be 51.2 into 10 to the power 2. Okay, and it comes 5120 meter. This is my answer. So simple. Okay, so they will just try to confuse you, so you do not get confused. You should know the basic idea how to solve the basic numericals. That's it. So RTT is given to us as 51.2 microsecond. From this you can calculate the propagation time. Speed of signal is given to us, and they are saying maximum length of Ethernet LAN. So they have just introduced this word Ethernet just to confuse you. So you might keep on thinking like there is some formula and so on, but there is no need of formula. You just know the basic mathematics. Distance is equal to speed into time. Multiply it, you will get the answer 5120 meter. That's it. Is it okay?
Sir.
Okay, so that's it. So this is all about my topic Ethernet. Ethernet is over. So now we can comfortably say that our data link layer is over. Okay, actually we have networking devices also, like a router, bridge, gateway and so on, but they are not in your GATE syllabus now. I think they were till 2018 or 2019. After that, from the past 3 years, they have excluded this topic. So we are not going into details of this just to save the time. If time will permit, I will cover that 100% after completion of this computer network subject. Okay, but it is not required for GATE. So why we should cover these extra topics if they are not in your syllabus? Okay, so already we have many things to cover. So first we will cover on the very most important topics which are needed for GATE. Okay, so that's it. This is all about your data link layer. Now we are going to start the network layer. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. Yes, so now we are going to start the network layer. So in the network layer, we are going to start the first topic, that is IP addressing. And almost every year you will face one question from this topic. Very important. IP addressing is very important topic. Okay, many times question have been asked. So try to focus here. So first of all, I will build basic background, then we will start this IP addressing topic. So we should know the basic thing. Why what is the basic responsibility of network layer? Network layer is responsible for host to host delivery of datagram. Host to host delivery of datagrams. That is the basic responsibility of network layer. Okay. And network layer, what network layer is adding? Only header. Data link layer was exception, which was adding header as well as trailer. But network layer add only header. So network layer add header. Okay. And this header contain what? IP address of both sender and receiver. And this header contain lot of extra thing. Don't worry, we have to study IP header properly. In IP header, I will tell you all these things. Okay. At network layer, which is the basic protocol which is working? IP. So IP header, that is very important topic. Don't worry, we will tell you that thing also, but after few lectures, when this IP addressing topic is over. So for now, we can just think like that. Network layer add header, network layer add header, and this header contain IP address of both sender and receiver. I think you already know. In data link layer, I have told you, data link layer add header which contain physical address of both sender and receiver if they are in same network. If they are in different network, then receiver will be the intermediate node. We have studied all these things in the previous lectures. Okay. So network layer add header, and this header contain IP address of both sender and receiver. Okay. Next, I think you already know, each computer connected to internet is having two addresses. I have told you, physical address as well as logical address. Physical address is your MAC address, which I have told you just now, Ethernet, and logical address is just like your IP address, which we are going to study now. So each computer connected to internet has IP address, which is used to uniquely identify it on the internet. Okay. So each computer connected to internet has IP address which is used to identify it uniquely in internet. Okay, so in entire internet, if you want to identify any computer uniquely, you should know its IP address. So presently we are in transition from IPv4 to IPv6. Okay, so if somebody asks you whether we are using IPv4 or IPv6, we are using both. Okay, some computers like old which have older versions of Windows and all, they are using IPv4. New versions are using IPv6, and some so there is, you can say, transition from IPv4 to IPv6. So 100% IPv4, no. 100% IPv6, no. So there are two versions of IP, that is IPv4 and IPv6, and presently we are in transition from IPv4 to IPv6. Okay, so let me write it. There are two versions. Two versions of IP, that is IPv4 and IPv6. Okay, and presently we are in transition from IPv4 to IPv6. Okay, IPv4 is of 32 bits and IPv6 is of 128 bits. IPv6 is not in your GATE syllabus. That is a good news to all of you. Until 2020, GATE 2020, IPv6 was there, but after 2020, IPv6 has been removed. So in 2021, 2022, 2023, it has not been asked. So it is not guaranteed that they might add this topic in 2024 and so on, like that. So they keep on changing small topics. So basic idea is till now, or rather IIT Kanpur has given the syllabus. You can check that out. IPv6 is not in your syllabus, so don't worry about it. Our main concentration will be on IPv4 only. This is in your GATE syllabus, and it is very important. Okay, so we will study IP addressing according to IPv4 only. Okay, Take the snapshot. I will jump to the next slide, and now I am going to start this IP addressing topic.
Done, sir.
Okay. IP addressing. So the basic idea here is, so first of all, we will try to answer very simple question. So very first question that comes to our mind is total number of IP addresses possible. Total number of IP addresses possible. Now do not say, sir, according to which version. There is only one version, IPv4, in your GATE syllabus. So if they are asking this question, they are by default considering IPv4 only. They are not considering IPv6. So don't worry about it. Total number of IP addresses possible will be, since IPv4 is of 32 bits, so total IP addresses possible will be 2 power 32. Any doubt? Okay, because 32 places 2 will be there. 2 possibilities, 0 or 1, 0 or 1, 0 or 1. 2 possibility why? Because 0 or 1. Another 2 possibility why? Because 0 or 1. So how many these are? 32. So 2 into 2, 32 times 2 power 32.
Yes.
Okay. Yeah. So roughly we will call it as 2 power 32. Roughly we will call it as 4 billion. 4 billion IP addresses roughly. Okay. So let me tell you. 2 power 10 is roughly 1000. Actually it is 1024. 1024. 2 power 10 is 1024. But roughly we will say 1000. Okay. 2 power 20, that is equal to 10 to the power 6, that is 10 lakh, and that is nothing but your 1 million. 1 million is 10 lakh, that is 10 to the power 6. 2 power 10 into 2 power 10, we will get 2 power 20. No, 1000 into 1000, that will be 10 power 6, that is 10 lakh, 1 million. Roughly we will say these things. Okay, don't worry. 2 power 30, that will be 10 to the power 9. Okay, and it is 1 billion. You should know this terminology. 2 power 10 is 1000, 2 power 20 is 10 lakh or 10 to the power 6, 2 power 30 is 10 to the power 9, that is 1 million. So if you try to remember, you can say like this. Even I used to remember like this. 1000 makes a million. 1000 million makes a billion. Okay. 1000 makes a million. So 1000 into 1000, you will get 1 million. 1 million. And 1000 million makes a billion. 1000 million makes a billion. Okay, like this you can remember. Yes, so you can take the snapshot. I will jump to the next slide. Done? Okay, so let me, yeah. Okay, so there are 3 kinds of notations which we are going to use. 3 kinds of notations. Okay, so very first is binary notation. There are 3 kinds of notation. Just a second. Yes. So the very first is binary notation. Next is dotted decimal notation. And the third one is hexadecimal notation. Okay. So there are 3 kinds of notations for IP addresses. Binary notation, that is simple. You write string of 32 bits. 1011011 like this, dot 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 dot. But it is not used. Why? Because human eye cannot see and cannot remember these binary numbers. Okay, it is not used generally. Dotted decimal notation, it is mostly used. Okay, so for example, let me give you some examples of dotted decimal notation. For example, I will say 36, 40, 50, 55 like this. Okay, dotted decimal means after 1 byte we will apply a dot. Okay, so dotted decimal means so you just take the binary. Okay, for example, I say 10 100 100 0 0 and then I am saying say 1100 like this, 2 3 4 5 6 7 8, then 1 2 3 4 5 6 7 8, and then 1 2 3 4 5 6 7 8, like this. Something I have written like this. Okay, so this is 32-bit. So what we will do, we will group 8 bits and write its decimal equivalent. So what will be decimal equivalent? If you try to know, this is 9 and after 0 8 18 36, so it is 36. What is this? And I will apply dot now. After this 1100 12 piche 0 means 24. What is this? 111, that is 7. What is this? This is what this is what will be this? 1 followed by 40, that means 16. 16 into 2 32 plus 1 33. 33, after that we have 133 66 or 67. 67, after that we have 167 into 2. What we will get? 67 into 2 plus 1 na? So 67 into 2, 135. 135, yes, plus 1 also 135. So 36.24.7.135, like this you will write. So in place of writing 32-bit string of binary, it is very difficult to understand. We will convert it into decimal. So that is dotted decimal notation. That's why we're calling it as decimal. Why decimal? Because you are converting this 8-bit to decimal value. So here 36, 24, 7, 135. I think everybody have got it. And one more thing, let me tell you what is the maximum value which you can get in 8 bits. That is 1 2 3 4 5 6 7 8. 8 ones. 8 ones is 2 power 8 minus 1, that is 255. So maximum value here can be 255. These are octets. These are known as octets. Why octets? Because 8 bits you are writing decimal. Okay, that's why octet. So each octet is a maximum value in octet can be 255. Minimum can be all zeros. 1 2 3 4 5 6 7 8. It is 0. So do not say minus 1 minus 2. They are not allowed. Okay, so octet minimum. Okay, let me write it. Octet minimum 0, maximum 255. I think you have got it, na?
Yes, sir.
Yeah, take the snapshot. I will jump to the next slide and then I will ask few questions regarding this dotted decimal notation. Take the snapshot.
That's
Okay. So if I write 123.40.60.270, is it valid IP address? 100%, no problem. There are four there are 4 octets. Okay, and everywhere no, it is not valid. Sorry, it is not valid. Why? Because where we have got this 270, 255, maximum is 255 only. Okay, 270 is not allowed. So this is invalid IP address. Okay, next if I write 121.41.45.60, yes, this is valid IP address, no problem. 4 octets and everything is fit and fine. Next if I write 221.34.7.8.2, is it valid IP address? No. Why? How you have got these 5 octets? There are only 4 octets. Okay. Next is say 75.45.301.41. No. How we have got this 301? Next 100.1100 4 times 1.128.14.70. No. How this mix up? Why this mix up? Binary and this thing not allowed. Okay, this is not allowed. Okay, yeah, so I think you have got the point. Yeah, and one more important question is coming to my mind. So if we write 123.45.036.78, is it valid? No, this 0 cannot come. This 0 means this number is octal. Okay, so we are not considering base 8 numbers. Okay, that's why. So I think you know these things in C language also. 036 is an octal number. Okay. It is not decimal. So before any number, 0 cannot be there. That is the basic thing.
Done, sir.
Any doubt?
No, no, sir.
Okay, take the snapshot. Then we will start the hexadecimal notation.
Done, sir.
Okay, so the last is this hexadecimal notation. So let me tell you that thing also. That is very easy. Hexadecimal notation. So for hexadecimal notation, we will use 0 small x or 0 capital X, and then simply we will convert binary into hexadecimal. So for example, I can write 3 6 A B C D E F like this. So you can check it out, 1 byte, 2 byte, 3 byte, 4 byte. Yes, this is perfect. This is okay. Another example can be A B 4 5 3 6 2 0. Okay, no problem. Okay, like this. So 0x or 0 capital X. Okay, that represent the hexadecimal values. So IP address, if they say IP address in this format, no need to worry, they are talking in hexadecimal notation. Similarly here also. But generally in GATE exam, in everywhere, in any competitive exam, if you find IP addresses, that will be in dotted decimal notation only. That is like this. Like this you will find. Okay, so our main concentration will be here only, like this. Okay, yes. So yeah, you can take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so the next type of question is, which they can ask is, they will ask you to find number of IP addresses in range. So let me write it. Find the number of addresses in range if first address is 146.102.29.0 and last address is 146.102.32.255. Okay, so if this is the scenario, then they are asking find the number of addresses in range. So this type of question I have been asked in GATE. So let me tell you the basic theory behind this type of question, then we will start them. So dotted, first of all, okay, let me jump to the next slide. In next slide I will tell you. You can consider dotted decimal notation. Consider dotted decimal notation as base 256. Base 256. Okay, so see this, why we are calling it as base 256, because in base 250, see this, in base 10 digits can be from 0 to 9 na? Similarly in base 256 digit can be from 0 to 255. This is what exactly we are using. So with separated by dots, so here we can write from 0 to 255, 0 to 255, here also and here also. So we are considering it as base 256. Another reason is, so when we are getting here 255, that is the largest digit possible here. When we add 1 here, then what we will get? We will get 1.0 here. Are you getting it?
Yes, sir.
Okay, so you can imagine also 255 means 8 ones. Whenever I will add 1 here, then we will get all the zeros and 1 here. So when we will convert it into decimal notation, then here we will get all the 0, here we will get 1. Okay, so after 255, here 0 and here 1 and so on. So that's why we are considering it as base 256 number. Okay, so this was a small hint. Now if I say like this, say I am subtracting 53 minus 21, base 10 subtraction I am doing. So what you will say, 3 minus 1, that is 2, and 5 minus 3, that is 5 minus 2, that is 3. 32 is your answer. So I can mold it and I can say like this: 3 minus 1 into 10 to the power 0, because their base value here, place value is 10 power 0, and here it is 10 power 1 na. So here I will write like this: 5 minus 2 into 10 to the power 1. So that's why what you have got is 3 into 10 plus 2, that is 32. Are you getting it?
Yes, sir.
So same scenario I will use here, okay, in the previous slide. And one more thing, if I say how many numbers are there in range from say 5 to 9, what you will say: 9 minus 5 plus 1 na, because 5 and 9 both are included. You can count that on your fingers also: 5, 6, 7, 8, 9. So total 5 numbers are there. But if you do 9 minus 4, you will get 4. 4 plus 1 you have to do. So in the end you have to add 1 also. Any doubt here?
Understood, sir.
Okay, now it's very simple. Now everything is over. So what will be our answer now? So 255 minus 0 into 256 power 0 plus 32 minus 29. 32 minus 29 into 256 power 1. And here 102 minus 102 0. 146 minus 146 0. That's it. So solve and get the answer. So what will be now? 32 minus 29. 3 into 256 plus 2 5, acha, plus 1 also, no, sorry for that, plus 1, because upper bound minus lower bound plus 1. Okay, so 255 plus 1. So 3 into 256 plus 256, that is nothing but 4 into 256. So if you face difficulty, convert into power of 2. It comes out to be 2 power 10, that is 1024 is the answer. So simple. Any doubt?
No, sir.
Okay, so take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So, okay, just for sake of practice, 146.102.29.0 to 146.102.29.36. Number of addresses in range. Upper bound minus lower bound plus 1. So 36 minus 0. And 29 minus 29, 0, 102. So everything is gone. 36 minus 0 plus 1. So it comes out to be 37 addresses. Very simple. Another question, say 146.102.29.0 to 146.104.30.5. So very simple. So you will say 5 minus 0 and then plus 30 minus 29 into 256 power 1 plus 104 minus 102 into 256 power 2. That's it. Okay, and plus 1 you have to do. So solve and get the answer. I'm not going into details of this, just to save the time. So you can
Thank you.
take the snapshot. Okay, okay. So that's it. I think now range question is will not create any problem in anybody's mind. So range type of question is over. Done. Now we will start the next type of question. Okay. So let me jump to the next slide. So they can just twist the question also. They will say if first address in the range is given as first address in range is 141.46.55.96, and they are saying if total IP addresses are 32, find the last address. How you will solve this question? So what they are saying is total addresses in range is 141 Sorry, first address in range is 141.46.55.96. Total IP addresses are 32, and we have to find the last address. So you just reverse the procedure. First address is this, na? So only 32 addresses are there. So 96 plus 32, you will say 6 plus 2 8, 128 is there. Okay, total 32 IP addresses were there. Last address you have to find. So for last address, since to get 32 you have added 1, so you will subtract here 1. So what will be our answer? 127. Please let me know if anybody is having any doubt. So okay, so let me write it. Last address, na? So last octet will be 127. So total final answer will be 141.46.55.127. This is my answer.
Done, sir.
Yes. Okay. So let me jump to the next slide. So now we are going to start some basic operations on IP addresses. Okay. So I am just building the background till now. Basic operations on IP addresses. The very first is bitwise not. We are going to use these things in subsequent slides, so please stay focused here. So bitwise not operation. So for example, IP address is given to us as 128.36.45.46. Roughly I have written. So this IP address is given and I want to find bitwise not of it. How you will find bitwise not? So for not operation, first of all you should know. For example, I am having some binary number, say 1011. If you do not, what you will get? 0100. How you will get this 0100? So you have just changed 1200 to 1. So directly and indirectly, if I say I am having 1011, so you subtract it from all ones. What you will get? 0010. Same answer. Same answer. Okay. So actually, we are saying that not operation means 1200 to 1. That is similar to saying as you subtract it from all the ones. Any doubt here?
Understood, sir.
Okay, so now it's very simple. So now this is octet, na, 8 bits. So if you want to do bitwise not, what you will do? From 8 ones you will subtract it. 8 1 is nothing but 1 2 3 4 5 6 7 8. That is 255. So you subtract it from 255. So you will say 255.255.255.255 and you subtract it, you will get the answer. So here what you will get, and you should know also this thing, that there will be no borrow kind of thing anywhere. Why? Because here we cannot have any number more than 255. Okay, so no need to find borrow. Very simple scenario. So it will be 9 and here it will be 209. Okay, and here 0 and here 1 2 210 and here it will be 9 and here it will be 1 219 and here what will be that? 7. Yeah, 127. Yes, that's it. This is my answer. Okay, so bitwise not is very easy. You subtract it from all ones. That's it. Or 255 255 255 255. Subtract it from all these. You will get the answer. Any doubt here?
Understood, sir.
Okay, so take snapshot. I will jump to the next slide.
Done, sir.
Okay, next is bitwise AND. So how you will do bitwise AND? Say 141.36.13.36. Here we have say 0. Here we have 255. Here we have say 12 and here we have say 14. So how you will do bitwise AND? So for bitwise AND means bit by bit you have to do AND operation, and for AND operation obviously we need 2 IP addresses. So I have taken it. So now if you try to imagine, I'm doing bit by bit and here we have 0. That means all zeros. So forget about here. Na, you will get 0. Any doubt?
Didn't understand, sir.
Please come again.
I didn't get it, sir. 36.
Okay,
and
okay.
0. This is an AND operation, like number and 0 is the answer.
So 36 is 100 100. and all zeros are there. So you just do bitwise and 0 0 0 0 0 0 0, everything will be 0.
Yes, sir.
And what about here? Okay, so let me tell you, this is AND gate. Now if one input is 1, here if we put 0, we will get 0.
Got it, sir.
Here if I put 1, here I will get 1. So here if 1 is fixed, then accordingly we will get the answer. So if we have 255 means all ones, 1 2 3 4 5 6 7 8, and here we have 13. So what is 13? 1101. So every last 4 bits will be 0. So if we do AND, but we will get 1 0 1 1, all the 4 zeros. So directly and directly whatever we have inputted, we have got it. So 13 will be our answer. So that is again very beautiful shortcut. If we have 255, then other number will be copy pasted as it is. If 1 is 0, then 0 will be pasted as it is. Any doubt here?
Understood, sir.
Okay, next is 36 and 12. So here you have to do binary. And there is no shortcut. So 36 is 100 100, and 12 is 1100. So where we will write it 1100. So here 0 0 0. Forget about all those. So I will simply write 0 0 1, and everywhere it will be 0. So 4 is the answer. Is it okay?
Answer.
Okay, and what about 141 and 14? 141 is a big number. 141. So see this. If we have 8 bits, so 1 2 3 4 5 6 7 8. So this place value is 128, 2 power 7. I think you know these things. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 5, 6, and 7. So now if I want to write binary of say 7, but I will say 2 power 2, 4 plus 2 plus 1, that is this is 7. Rest everything will be 0. Okay, if I want to write 11, 11 is 8 plus 3, 8 is this, and this is this, 11 is over. Okay, like this you can write any binary number with this. Okay, if I want 36, so 36 means what? 32. This is 32. 2 power 5 is 32. 32 plus 4 36 na. So 4 is this. So this is 0 0, like this. Okay, so now if I want to write 141, 141 means 120, 2 power 7, that means 128 will be 1. Okay, and 141 minus 128, what will be our answer? 11 3, and here 13. 13 is left out. Are you getting it? So how you will imagine 13? 1101. Okay, and below that we have 14. So now my major concern was that in GATE exam, no need to do this kind of basic thing. You should say 141, that is a very huge number, 14 is very less. So according to 14, you just simply check it. 14 is 111110, and 141, here we have 1, and after that we have 13. So you should simply do AND of 14 and 13. So you will get 0011. So answer is 12 directly. And I have ignored this here 1. So here everything is 0. Now since here everything is 0, so we will get 0 only. Okay, so finally we will get zeros only. So here we will get only 12 as the answer. Directly you can do these things. Okay, so you can do these shortcuts in GATE exam just to save the time. We have to do many times bitwise AND operation. Don't worry, these are the basic concepts of your IP addressing topic. Okay, any doubt here?
Clear, sir.
Okay, so let me do another question just to give you clarity. Take snapshot.
Done, sir.
Okay, now if I am saying 192, okay, I think slides are over. Let me take that. Yeah, so 192.45.255.0, and here 30, 50, 40, 36. So first of all, let me tell you these things. These numbers will be used in IP addressing many times. 128, that is 1 followed by 7 zeros. 1 2 3 4 5 6 7. 120, 2 power 7. 2 power 7, that means 1 followed by 7 zeros. Let me tell you that shortcut also. 32, how you will write 32 binary? 32 is 2 power 5. 2 power 5 is 1 followed by 5 zeros. That's it. Okay. 64, 64 is 2 power 6. 2 power 6 means 1 followed by 6 zeros. That's it. Okay, 128 is 2 power 7. 2 power 7 means 1 followed by 7 zeros. That's it. Shortcut. Okay, and next is 192. 192 is 128 plus 64. 128 plus 64, that means first two ones. Then 1, 2, 3, 4, 5, 6. Okay, yeah. And next number is plus 32. 192 plus 32. It will be uh, 2214. 214 is another beautiful number which you should. Okay, let me check that out if I have done some mistake. 192 plus 32. Okay, 190, 128 plus 64 is what? 128 plus 64. 192, it's okay. Then 192 plus 32. 214.
214.
Okay, so what is okay? No problem. 214. 214 is also a beautiful number. Triple one and here four 5 zeros. Okay. Yes. So like this, you should remember these few numbers. If you remember these in gate exam, you will get tremendous speed. So now try to imagine in 192. Do it in your mind. In 192, first two ones are there. Now these two ones will not be there in 30. You will get 0 as the answer. Are you able to do it?
Yes, sir.
Okay, so this will give you tremendous speed. Now 255 and 40, all ones are there. 40 copy pasted. 0, 36, 0 will be copy pasted. 45 and 50, we have to do it. So what is 45 and what is 50? You have to do it. So 45, 1 0 11 1, 11, 22 and then 45. 50. What is 50? 50 is 11 00 10. Okay, this is 50 na. Why 12? 12 after 1 we have 25, 25 after 0 we have 50. Yes. So now you have to do it. No shortcut here. So we will get this. So that is 32. Is it okay?
Yes, sir.
Okay. So you can imagine these things. It will save our time. Take the snap and don't worry, when we will dig deep into the topic, I will give you many shortcuts. If I give you all the shortcuts at the same time, then obviously you will get confused and you will feel bored because I have not given you any application of these. So when we will do the application, when we will do solve question, at that time I will give you shortcuts so that you get more clarity. Okay, take the snapshot. I will jump to the next slide.
Done, sir.
And so last operation, that is bitwise OR. So bitwise AND was our second operation. Bitwise NOT was our first operation. NOT is very easy. You just have to do subtract from 255. Bitwise OR, same scenario. Okay. For example, if I say, okay, let me copy these numbers only so that we can solve them easily. If I copy it, your screen share will go on. So I have to. Okay, no problem. I will write it myself. 141, 36, 25. Yeah.
I can dictate, sir, if you want to copy the same.
Yes. 141, 36, 2550.
141, sir, actually 141, 36, 13, 36 actually it is.
Okay, 141, 36, then?
13.
Then, okay, 13.
36.
Again 36.
Yes, sir.
Okay. Next.
14, 12, 255. 0.
0. Okay, so now we want to do OR. OR means if any one of its input is 1, output of OR is 1. Na? I think you know this thing. So 36 is 100 100, and here we have all the zeros, 8 zeros, and here this. So if we do OR operation, so 1 or 0 is 1. You know these things, na?
Sir.
So finally we will get 36. So if any one of it input is 0, then you will get number as it is. Okay, and here 255 and 13. No need to check 13. Here we have 255. You will get 255. That is for sure because all ones are there.
Yes.
36 and 12 we have to do it. No shortcut. 100 and then 1100. and here we have 0, so forget about them because they will be zeros only. So 1 0 1 1 0 0. So what it will be? 44. 11 11 after 11 into 4. This is 4 na. 11 into 4 44. So 141 and 14. So 141 and 14. Now we have to do it properly. Okay. So what is 141? 128 plus 13 na. So 00001234567 8. Yes, 100011101. 141 is ready. 14 was 1110, and everything here will be 0. So what we will get? 1000114 ones. So what I will say, I will simply say that here it was 0 and now it has become 1. So you just add 2 to it. It will be 143. Any doubt?
Done, sir.
Okay, that's it. So this is our OR operation. Okay, so and let me solve 1 or 2 questions just for the sake of completion. I will do it randomly. Take the snapshot.
Done, sir.
Okay, so next is 0 2 5 5 16 127, and here say 30 40 15 and 128. So what we will say now? 0 30 30 is the answer. 255 40 255 is the answer. 16 15 we have to do, and rather I should say one more thing. I think I have told you now, 4 times 1, that is 15. Why? 2 power 4 minus 1. I have
Yes,
told you
sir.
the shortcut. 1 2 3 4 5 6 6 ones, that means 2 power 6 minus 1, that is 63. 1 2 3 4 5 6 7 7 ones means 2 power 7 minus 1, that is 127 63 15. And 16 is what? 2 power 4, that means 1 followed by 4 zeros, and here we have 4 ones, so nothing is common between them. So what I will get? All ones I will get. So what I will get? It is 31. Any doubt?
Nice, sir.
And here 127 and 128, nothing is common between them. 127 is 7 ones and 128 is 1 followed by 7 zeros. So what I will get? I will simply add them, that is 255 is the answer. Okay.
Done, sir.
These type of shortcuts we should know. So finally, I will write the summary. Take snapshot. I will jump to the next slide, and I will write the summary of this. Okay. So final summary. For NOT operation, what you have to do? 255 minus x. That's it. Just subtract it from 255. For AND operation, if we have 255 and x, you will get x as the answer. If you have 0 and x, you will get 0 as answer. For OR operation, 255 and x, you will get 255 as answer. And if we have say 0 and x, you will get x as answer. Sorry, or na. Sorry. Or 255 or x, 0 or x. So 255 and here x. Any doubt?
No, sir.
Okay, so now let me start the proper topic. Take the snapshot. Done?
Sir.
Okay. So now we are going to start class full addressing. Class full addressing. Okay, let me tell you one thing. It is not used nowadays. It was just a theoretical concept. Rather, it was used, but for few years it was used, and then it was thrown away, and classless addressing come into the picture. So why classless come? What was the problem in classful? We will study these topics here, and GATE point of view, it is very important topic. So many times question have been asked. So please be careful. So for classful addressing, let me tell you this thing. Total IP addresses are 2 power 32. Total IP addresses are 2 power 32. So in classful addressing, we have divided this total 2 power 32 IP addresses into 5 classes. Okay, Classful means divide this 2 power 32 addresses into 5 classes. Okay, what are these classes? Class A, class B, class C, class D, and class E. Total 5 classes. So there are 4 octets. Now I'm telling you how they are divided. There are 4 octets. So what they are saying is, for class A, first octet first bit is 0. Okay, class A first octet first bit is 0. So please let me know how many IP addresses will be there in class A. So first bit is 0, rest other 31 bits are there. So rest other 31 bits, 2 to possibility, 2 power 31. So in class A, total 2 power 31 IP addresses are there. So if I consider this as 2 power 32, so from this I have divided it into 2 parts. Half is given to class A. Why half? Why half? Because total are 2 power 32 and 2 power 31 are gone. So how many are left out? So 2 power, so you can divide it by 2, rather 2 power 31 divided by 2 power 32, that is 1 by 2, that is half is given. Or you can think like this also, 2 power 31 into 2, this is what? 2 power 32. So into 2. Any problem here?
No, no, understood.
Okay. So class A is half, 50%. Let me write it, 50%. 50% of IP addresses are given to class A. Next is class B. So for class B, they are saying first 2 bits are reserved, 1, 0. So how many IP addresses will be there? Only 30 bits can move, that is 2 power 30. 2 power 30 and 2 power 32. What is the relation? 1 by 4. 1 by 4. So class B is 1 by 4, that is 25%. Any doubt?
No, no, sir.
Okay. For class C, they are saying 110. 3 bits are reserved. So total IP addresses are 2 power 29. That is 1 by 8. 1 by 8 is 12.5%. So class C is 12.5% of total IP addresses. For class D, it is 3 times 1 and 0. 3 times 1, 0. So it will be 2 power 28. So 1 upon 16. 1 upon 16 is 6.25%. Yes, any difficulty or it's okay?
It's okay, sir.
Yes, so 6.25% is class D. And for class E, it is 4 ones. So again same 2 power 28 because 4 bits are reserved, na, that's why. So same answer. So class E will be again 6.25. Class E is also 6.25%. So now let me build a small picture in front of you so that you get more clarity that how these classes were divided. Take the snapshot, I will jump to the next slide. These are very important, by the way. Okay, 50% IP addresses is with class A, 25 with class B. So largest class is class A. Smallest classes are D and E. They are of same size. Okay. Yes. So let me jump to the next slide. So there are total 2 power 32 IP addresses. We have divided it into 2 parts. So in first part I am saying first bit is 0, and in the second part I am saying first bit is 1. So this is given to your class A. Okay. Now if first bit is 1, then again I am dividing it into 2 parts. First part is 1, 0 and next part is 1, 1. Are you getting it?
Yes, sir.
So this 1 0, is given as class B. This 1 1 again, it is divided it into two parts, 110 and 111. This 110 is given to class C. This 111 is divided it into two parts, 110, and next will be obviously what, 1111. So this is given to class D and this is given to class E. Are you getting it? So we have just divided it into, okay, so you can imagine it just like a circular cake we are having, half, then 1/4, then like this.
Yes, sir.
Okay, so this is your classes. Take snapshot.
Done, sir.
Okay, so now they are going to ask about first and last addresses. So let me tell you that also. So how you will find first address of class A? Okay, let me, okay, I have to do it here itself because it will be easy to visualize. So first address of class A will be what? Can you tell me? All zeros will be there, na? Here 0. So rest other 31 bits are all zeros. So you will get 0.0.0.0. What will be the last address of class A? So all ones you put. If you put here all ones, what you will get? 127. Are you getting it? Because first bit is 0. 7 1. 7 1 is 127. Any doubt?
No, no, sir.
And here 255, 255, 255. 127.255.255.255. Now please tell me here. Okay, let me push it a little bit down. Yes. So here also. Oops. Yes. Okay. So please tell me now from where I will start until where 1 0 I'm having. So 1 0 means 2 bits. Now 6 bits are there. So if all these 6 bit will be 0, what you will get? 1 followed by 7 zeros. 1 followed by 7 zeros is 128. And rest all will be zeros. 0.0.0. Any doubt?
So how class 127? I did not understand. I missed it.
Okay, so 0, then last address I am calculating. Last address means all ones you will put. So 1, 2, 3, 4, 5, 6, 7.
Yes, sir. Understood.
It is, yeah. And class B 1 0, and here 6 zeros will be there, na? So 128.0.0.0. And now last address I will put 6 ones. So 1 0, then 6 1. What is 6 1? 6 1 is 63. And this is 128. 128 plus 63, what you will get? 191. 191.255.255.255. Any doubt here?
No, no, sir.
Okay, so next is class C. Class C, let me take it. Yeah. So tell me what will be the first address? 110 and all zeros will be there. I have told you special number. 11, then followed by 6 zeros. 192. 192.0.0.0. Till what point we will go? 110, and then we have 5 ones. Na? 5 ones, if you put 5 1 is 31. So 192 plus 31, what we will get? 213. Any doubt?
No, sir.
Oh, 213 or 223? 223. 223. You can add it. 192 plus 31. 223. Yes, 223.
Yes, sir.
223 dot. And here it is very obvious. 255. .255. Next. Class D. So class D 1110 and rest other 4 bits will be 0. So 111 I want to just check. 128 plus 64 plus 32, that is 224. I think in the previous slide we have done a mistake. That's why I was getting problem here. So 224, 9 plus 3 is 12 na. That's why I was thinking that how we are getting 214. It was not a number which is in my mind. So it should be 224. 111 is 224. Yes, there was small calculation mistake. Yes. Yeah. So now why I have got 224? I think you have got it 111 na. So 128 plus 64 plus 32, that is 224. Okay. Then this is very obvious, 0 0 0. Till what point we will go? 1110, and then we will add 4 ones. 4 1 means 15. 4 1 is 15. Add 15. 239. .255. .255. .255. Any doubt here?
No, sir.
Okay. So the last class E, from where we will start, 4 ones. 4 ones, continuous 4 ones. Continuous 4 ones is 128, 64, 32 and 16. You add them. I will simply say plus 1. 239, it will be 240. .0 until what point we will go? All ones. Now, so here all ones. Sorry, here all ones. Here all ones. So it will be 255. .255. .255. .255. And doubt?
No, sir.
Okay. So you can take the snapshot. I will jump to the next slide.
Done, sir.
So next we are going to start a beautiful concept, that is net ID and host ID. Net ID and host ID. So what is net ID? Net ID is network identification. Network identification. Host ID is host identification. Okay. Net ID is network identification. Host ID means host identification. So host ID is very simple. Host ID means every computer, I have told you, every computer connected to internet must have an IP address, and that address is nothing but your host ID. So please write down, every computer connected to internet must have an IP address. Every computer connected to internet must have an IP address, and that address is host ID. And that address is host ID. Okay. Yeah. And now imagine, see, total number of IP addresses possible are 2 power 32. So theoretically, let me write it properly. Theoretically saying, actually number is very less. I will tell you why number is less, but I am telling you theoretically. Theoretically, we can have 2 power 32 computer connected to internet at a time. 2 power 32 computer connected to internet at a time. Connected to internet at a time. Actually, sorry, we should say number is quite big, rather it is very high. It is more than 2 power 32. 2 power 32 is what? It is 4 billion. 4 billion means actually number is much more than this. Okay, why number is much more than this? Don't worry, I will tell you about that also. Okay, but theoretically I can say 2 power 32 computers can be connected to internet at a time. So if I want to do routing, that means any computer can send data to any other computer in the world. So if I want to do routing, then each router in the internet must have, routing means to place the packet en route to destination. I think I have told you many times in the previous lectures also. So I just want to place packet in its routes to destination. So if I want to do routing, then each router must have 2 power 32 entries, because one entry for each computer, that is for sure. If it in its routing table, if it is not having entry for a computer, then how it will forward the packet? Okay, so roughly I am telling you that to make routing process possible, each router in internet must have 2 power 32 entries. Let me write it. 2 power 32 computer connected to internet at a time. Roughly I am saying, or theoretically rather. Okay, I have written here theoretically. No need to worry. Yes, so there is nothing wrong. Theoretically, 2 power 32 computer can be connected to internet. So to make routing process possible, or so each router must have 2 power 32 entries in its table to make routing possible. Okay, otherwise routing will not be possible. Now if entry is missing, then how you will route the packet? That is impossible. Okay, so now see the problem. If each router is having 2 power 32 entry, 2 power 32 is 4 billion entry. So searching an IP address in that table, that will take a lot of time. Okay, searching need lot of time. Searching need lot of time. Okay, so in order to avoid this scenario, concept of net ID was developed, or network identification was developed. Okay, so concept of net ID was developed. Concept of net ID was developed to decrease entries in routing table. Okay, to decrease number of entries in routing table, concept of net ID was developed. So what is net ID? So like what is host ID? Each computer connected to internet must have an IP address, that is known as host ID. So just like each computer connected to internet has an IP address, similarly each network connected to internet must also have an IP address, that is known as net ID. Okay, are you getting it? So if we have a LAN like this, so I will reserve one IP address for this LAN, and each computer will definitely have an IP address. Okay, each computer will have one IP address. And what about this entire LAN? This entire LAN, I will give one IP address to this also. Okay, and this IP address will be the first address in the block. See, block by block we will give IP address to the LANs. Okay, so one block of IP address I will take and I will give it to this LAN, and the block starting address will be the net ID. Are you getting it? So now what is the advantage? In place of storing IP addresses of each and every computer in this network, router will store only first IP address of the block, that is net ID. Okay, so now router entire concentration will be to put the packet in this LAN, and the moment packet arrives in this LAN, now it's responsibility of this LAN to forward the packet to the respective computer. Okay, so it's just like that. If you want to send a letter to some person in US, so first responsibility is from your city, it should go to US, and then from US it's responsibility of post office of US, that where in which city and where packet will where this letter will go, and so on, like that. Okay, so we have bifurcated the task. So so router main concentration will be to put the packet in this network. Once this packet reach this network, then it's responsibility of this network to put the packet to the respective computer. Are you getting it? So that's how we can decrease the number of entries in routing table. Any doubt here?
Understood, sir.
Okay, so you can just write 1 or 2 lines. Please write down, because it will confuse you. After a few slides it will confuse you, so better you should write it. What is net ID? Like each computer connected to internet has IP address. Like each computer connected to internet has an IP address. Each network or LAN which is connected to internet also has IP address. Like each computer connected to internet has IP address. Each network or LAN which is connected to internet also has IP address. Each network or LAN which is connected to internet also has IP address. Okay, and what is this IP address? This I have told you, this IP address is the first IP address of the block, okay, which is given to the LAN. Write it. This IP address is the first address in block of addresses given to LAN. This IP address is first address in block of addresses given to LAN. Okay, this IP address is first address in block of addresses given to LAN. Okay, and also you should know that this is a reserved address. This IP address will not given to any computer in the LAN because it will create conflict. Okay, so this is reserved IP address. So if you assign a block to a LAN, then first address is reserved as net ID, and this address cannot be given to any computer inside it. Okay, please write it. It is not assigned to any computer or router in LAN. It is not assigned to any computer or router in LAN. Okay, so what is its use? Its use is in routing only. Okay, so routers in the internet will not store entry for each and every computer in this LAN. Rather, they will store only one entry that is for this entire LAN, and that is the first address. Okay, please write it. It is just used for routing. Because you might argue, sir, why we are using it when it is reserved, it cannot be given to computer. We are just using it for routing. So it is just used for routing, and in place of having entries for all addresses, it is just used for routing, and in place of having entries for all the addresses, internet router keep only net ID of LAN. Internet router keep only net ID of LAN. Internet router keep internet routers. Internet routers, that means routers which are present in internet. Okay, internet routers keep only net ID of LAN. Keep only net ID of LAN. Okay, so that's it. Our basic concept is over. So now we will dig deep into this topic in the next class only. Okay. Yes, if anybody is having any doubt, you can ask me. Otherwise, we will wind up the class here itself.
Done, sir.
Okay then. Bye bye. Good night.
Good night, sir.